Hospital-grade receptacles are generally required in all diagnostic areas because of electrical safety. Hospital-grade receptacles are designed to meet higher electrical safety standards, ensuring patient safety and preventing electrical hazards. They feature tamper-resistant features, ground fault circuit interrupters or GFCIs, and isolation transformers, which reduce the risk of electrical shocks and fires. Medical diagnostic equipment often requires a clean and stable power supply, and hospital-grade receptacles provide this. They are designed to minimize electrical noise and interference, ensuring accurate and reliable readings from medical devices. In critical medical areas, redundant grounding is essential to maintain continuity of the ground path and prevent electrical hazards. Hospital-grade receptacles have multiple grounding terminals, providing multiple paths for grounding. Isolation transformers in medical receptacles provide electrical isolation between the equipment and the power source, which is crucial for preventing ground loops and ensuring patient safety. In many countries, regulations and standards such as the National Electrical Code require hospital-grade receptacles in diagnostic areas to ensure patient safety and adherence to electrical codes. Therefore, to ensure the safe and proper functioning of medical diagnostic equipment, hospitals are required to install hospital-grade receptacles in all diagnostic areas. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. Several articles within the NEC pertain directly to healthcare facilities and the specific requirements for hospital-grade receptacles. These articles aim to minimize electrical hazards and ensure the reliable operation of medical equipment. Article 517 of the NEC covers healthcare facilities, addressing the specific electrical requirements for patient care areas. This article differentiates between general care areas and critical care areas, each having its own set of standards. Hospital-grade receptacles are mandated in patient care areas to provide a higher level of electrical safety. Within Article 517, specific sections detail the requirements for receptacles in patient care areas. For example, Section 517.16 specifies that receptacles in patient bed locations must be hospital-grade and identified by the words hospital-grade or a green dot. This ensures that only receptacles meeting stringent standards are used in close proximity to patients. Article 250 of the NEC addresses grounding and bonding, which are crucial for electrical safety in healthcare facilities. Proper grounding ensures that fault currents have a safe path to ground, minimizing the risk of electric shock. Hospital-grade receptacles play a role in maintaining effective grounding systems by providing reliable grounding connections. Section 250.146 outlines the requirements for grounding receptacles, including hospital-grade receptacles. It emphasizes the importance of grounding continuity and the use of listed grounding devices. Article 406 of the NEC covers the general requirements for receptacles, cord connectors, and attachment plugs. While not specific to healthcare facilities, this article provides the baseline standards for all receptacles, including hospital-grade receptacles. Section 406.15 details the requirements for tamper-resistant receptacles, which are often a feature of hospital-grade receptacles. These receptacles prevent the insertion of foreign objects, enhancing safety, particularly in areas accessible to children. Hospital-grade receptacles are designed and manufactured to meet specific performance criteria, ensuring their reliability and safety in demanding healthcare environments. Several key features distinguish hospital-grade receptacles from standard receptacles. Firstly, hospital-grade receptacles undergo rigorous testing to ensure they can withstand frequent use and maintain their electrical integrity. They are subjected to tests for durability, impact resistance, and resistance to corrosion and chemicals commonly found in healthcare settings. Secondly, hospital-grade receptacles feature robust construction with high-quality materials. They are designed to provide a secure and reliable connection, minimizing the risk of loose connections or arcing. These minimize electrical hazards. Thirdly, hospital-grade receptacles include enhanced grounding features to ensure a low-impedance ground path. This is crucial for minimizing the risk of electric shock and ensuring the proper operation of sensitive medical equipment. Some hospital-grade receptacles have multiple grounding contacts to provide redundant grounding paths. Fourthly, hospital-grade receptacles often incorporate tamper-resistant features such as spring-loaded shutters that prevent the insertion of foreign objects. This is particularly important in areas where children or patients with cognitive impairments may be present. Fifthly, hospital-grade receptacles are clearly marked with the words hospital-grade or green dot to ensure easy identification. This helps to prevent the accidental use of standard receptacles in patient care areas. The installation of hospital-grade receptacles requires careful attention to detail to ensure compliance with electrical codes and standards. Following best practices during installation minimizes the risk of electrical hazards and ensures the long-term reliability of the electrical system. Firstly, ensure that the electrical system is properly grounded and bonded in accordance with the NEC requirements. This includes verifying the integrity of the grounding electrode system and the bonding of all metal enclosures and braceways. Secondly, use appropriate wiring methods and materials for the installation of hospital-grade receptacles. This may include using shielded cables to minimize electrical noise and interference, and using corrosion-resistant materials in damp or wet locations. Thirdly, follow the manufacturer's instructions for the installation of hospital-grade receptacles. This includes using the correct torque settings for terminal screws and ensuring that all connections are secure. Fourthly, inspect and test the installed hospital-grade receptacles to verify their proper operation. This includes performing continuity tests, voltage tests, and ground impedance tests to ensure that the receptacles are functioning as intended. Fifthly, document the installation of hospital-grade receptacles, including the location of each receptacle, the date of installation, and the results of any tests performed. This documentation can be helpful for future maintenance and troubleshooting. Several types of medical equipment necessitate the use of hospital-grade receptacles due to their sensitivity to electrical disturbances and the potential for electrical hazards. Understanding which equipment requires these specialized receptacles is crucial for ensuring patient safety and the accurate functioning of medical devices. Firstly, patient monitoring equipment such as electrocardiographs or ECG, electroencephalographs or EEG, and vital signs monitors require hospital-grade receptacles to ensure accurate and reliable readings. These devices are highly sensitive to electrical noise and interference, which can distort the signals and lead to inaccurate diagnosis. Secondly, diagnostic imaging equipment such as X-ray machines, computer tomography or CT scanners, and magnetic resonance imaging or MRI systems require hospital-grade receptacles to provide a stable and clean power supply. These devices generate high levels of electromagnetic interference, which can affect the performance of other equipment and pose a risk to patients and staff. Thirdly, life support equipment, such as ventilators, infusion pumps, and dialysis machines, require hospital-grade receptacles to ensure uninterrupted operation. These devices are critical for maintaining patient health and safety, and any disruption in power supply could have life-threatening consequences. Fourthly, surgical equipment, such as electrosurgical units, surgical lasers, and endoscopic devices, require hospital-grade receptacles to minimize the risk of electrical shock and fire. These devices operate at high voltages and currents, and any fault in the electrical system could pose a significant hazard to patients and surgical staff. Fifthly, laboratory equipment, such as centrifuges, autoclaves, and blood analyzers require hospital-grade receptacles to ensure accurate and reliable results. These devices are used for critical diagnostic tests and research, and any malfunction could compromise the integrity of the results. Regular inspection and maintenance of hospital-grade receptacles are essential for ensuring their continued reliability and safety. Over time, receptacles can become worn, damaged, or loose, which can increase the risk of electrical hazards. Firstly, perform visual inspections of hospital-grade receptacles on a regular basis to check for signs of damage, such as cracks, loose connections, or discoloration. Pay close attention to receptacles in high-use areas or areas exposed to moisture or chemicals. Secondly, test hospital-grade receptacles periodically using a receptacle tester to verify their proper operation. A receptacle tester can check for common wiring problems, such as open grounds, reverse polarity, and hot neutral reversals. Thirdly, tight and loose connections on hospital-grade receptacles using a screwdriver or wrench. Loose connections can cause overheating and arcing, which can lead to electrical fires. Fourthly, replace damaged or worn hospital-grade receptacles with new ones. Use only hospital-grade receptacles that meet the UL 498 or equivalent standards. Fifthly, keep hospital-grade receptacles clean and free from dust, dirt, and moisture. Use a dry cloth or vacuum cleaner to remove any debris from the receptacle face and surrounding area. In addition to hospital-grade receptacles, several other electrical safety devices are commonly used in diagnostic areas to protect patients and staff from electrical hazards. These devices provide additional layers of protection and help to ensure a safe electrical environment. Firstly, ground fault circuit interrupters, or GFCIs, are used to protect against electrical shock by detecting ground faults and interrupting the circuit. GFCIs are typically installed in wet locations, such as bathrooms and near sinks, where the risk of electric shock is higher. Secondly, isolation transformers are used to isolate electrical equipment from the main power supply. Isolation transformers reduce the risk of electric shock by preventing ground loops and limiting the amount of current that can flow through a person's body. Thirdly, line isolation monitors, or LIMs, are used to monitor the isolation of electrical circuits in operating rooms and other critical care areas. LIM provide an early warning of potential ground faults, allowing staff to take corrective action before a shock hazard develops. Fourthly, surge protective devices, or SPDs, are used to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD divert excess voltage away from the equipment, preventing damage and ensuring reliable operation. Fifthly, uninterruptible power supplies, or UPSs, are used to provide backup power to critical equipment in the event of a power outage. UPS ensure that essential medical devices continue to operate during a power failure, protecting patient safety and preventing disruptions in care. Understanding the potential electrical hazards in diagnostic areas is crucial for implementing effective safety measures. Electrical hazards can arise from various sources, including faulty equipment, improper wiring, and human error. Firstly, electrical shock is a serious hazard that can occur when a person comes into contact with an energized conductor. The electrical shock can cause muscle contractions, burns, and even death. Secondly, electrical burns can occur when electrical current passes through the body. Electrical burns can be severe and may require extensive medical treatment. Thirdly, electrical fires can occur when electrical equipment overheats or short circuits. Electrical fires can spread rapidly and cause significant damage. Fourthly, electromagnetic interference, or EMI, can disrupt the operation of sensitive medical equipment. EMI can be caused by various sources, including radio transmitters, cell phones, and other electronic devices. Fifthly, static electricity can damage sensitive electronic equipment and cause inaccurate readings. Static electricity can build up on clothing, furniture, and other objects, and can discharge when a person touches a conductive surface. Several strategies can be employed to minimize the risk of electrical hazards in diagnostic areas and create a safer environment for patients and staff. Implementing these strategies requires a comprehensive approach that addresses equipment maintenance, staff training, and adherence to safety protocols. Firstly, implement a regular maintenance program for all electrical equipment to ensure that it is in good working order. This includes inspecting equipment for damage, testing for electrical safety, and repairing or replacing any faulty components. Secondly, provide comprehensive training to all staff members on electrical safety procedures. This includes training on how to identify electrical hazards, how to use electrical safety devices, and how to respond to electrical emergencies. Thirdly, enforce strict adherence to electrical safety protocols, such as using proper grounding techniques, avoiding the use of extension cords, and reporting any electrical problems immediately. Fourthly, conduct regular safety audits to identify potential electrical hazards and ensure that all safety measures are being followed. Fifthly, use signage and labeling to clearly identify electrical hazards and safety precautions. This includes labeling receptacles with voltage and amperage ratings, and posting warning signs in areas where electrical hazards are present. In summary, hospital-grade receptacles are mandated in diagnostic areas to uphold stringent electrical safety standards, ensuring patient well-being and averting electrical risks. These receptacles come equipped with features like tamper resistance, ground fault circuit interrupters, and isolation transformers, significantly diminishing the potential for electrical shocks and fires. Furthermore, they guarantee a consistent and unpolluted power source essential for the dependable functioning of medical diagnostic tools. Adherence to regulations such as the National Electrical Code is crucial, emphasizing the necessity for healthcare facilities to install hospital-grade receptacles to safeguard both patients and equipment. Regular upkeep and thorough training are vital in preserving the efficiency and safety of these electrical components, underscoring their pivotal function in healthcare environments.